reactions that we need to actually do here. All right, some of the, let's just say basically look at the answer, what they mark here if they are correct, or some of them they are not answered, I will give answers to them, and then basically general correction. Now we have the first question here that says the following are true about alkenes except. This is something that we have done, right? Now, the following are true about alkenes except they can be hydrolyzed. Can alkene be hydrolyzed? Hydrolysis means addition of water and then breaking it down. Now, they can be hydrated, they can react with sulfuric acid, and then they can be polymerized. Now, alkenes can actually react with sulfuric acid. It's part of the reactions that we have here. Under reactions of alkenes, we have addition of hydrogen halides. Then 2, the second reaction of alkenes, we have, I think that one took a longer time. Then the second reaction is addition of hypophallus acid, right? And then the third reaction is addition of sulfuric acid, H2SO4. Now, when alkene reacts with sulfuric acid, they form the alkyl hydrogen sulfate. Is that okay? Sulfuric acid undergo addition to an alkene just as hydrogen halide does. This product is alkyl hydrogen sulfate. That is what is formed. A Markovnikov rule is applied. Then we have addition of water, which is hydration. Then we have, after addition of water, which is hydration, we have addition of halogens. And I think that is the last reaction. No. Then which other reactions we have here? Addition of carbene, addition of halogen and water. Then oxymercuration, demercuration of alkane. And then we have hydroboration, oxidation of alkene. And then I think that is basically all the reactions we have in alkene. Then addition of hydrogen to give us alkanes, of which we have discussed before. And oxidation with hot KMlO4, catalytic oxidation, then oxidation with ozone, then oxidation with cold KMnO4. The reactions of alkanes are quite broad, but none of the reactions involve hydrolysis. They can be hydrated. Hydrated means you can add water to alkane. So this one is correct. They can react with sulfuric acid. We've said they can react with sulfuric acid. They can be polymerized, yes. For instance, the polymerization of ethene is what gives rise to polyethylene. Is that okay? So the correct answer to this question is option A, they can be hydrolyzed. We are looking for the one except the one that is not correct. All right? So option A, it cannot be hydrolyzed. Is that okay? Now, option B, the ozonolysis of this we give. Now, ozonolysis is one of the reactions of alkanes. Now, we'll talk about ozonolysis. We are talking about the addition of what? Ozone. Then after adding ozone, which will form the molozonine, the ozonine, and then the alkene will split. There will be cleavage at the site of the double bond to form 2 carbonyl compounds, which could be 2 aldehyde, 2 ketone, or a mixture of aldehyde and ketone. Now, if you look at this question very well, the ozonolysis of this compound we give. Now, we said it can form 2 aldehyde, it can form 2 ketones, it can form a mixture of aldehyde and ketone. Now, the carbonyl compound that will be formed is dependent on the nature of the alkene that is given. The structural way or the structure of the alkene that is given will determine whether it will give an aldehyde, a ketone, or a combination of aldehyde and ketone. Now, generally, for this reaction, it usually splits at this corner. That is how I'm going to do it. So when there's splitting at this corner, what are you now going to form? You form arrow. Here will be C, arrow, double bond O plus, then this other side, double bond O. You just split it and add oxygen to the end. Here's arrow prime, and here is what? Arrow, and here is H rather. If you look at the structure very well. This is an aldehyde. I mean, this is a ketone, and this is an aldehyde. We said differences between ketone and aldehyde is what? Aldehyde, they are usually in this form. They have hydrogen ending it. While ketone, they are usually in this form. So this one we give an aldehyde and a ketone. All right. It will not give acid and alcohol, no. It will give an aldehyde and ketone, yes. It will not give two aldehydes. It will not give two ketones. The correct answer is what? An aldehyde and a ketone, which is option B. Now, the next one. Which of the following about laboratory synthesis is not correct? A, new drugs are produced. B, of course, laboratory synthesis, we can actually produce new drugs. B, it makes herbal treatment more convenient. No. The idea of laboratory synthesis actually paved the way for modern medicine, synthetic drugs, as compared to herbal and orthodox medicine. All right? So this option here that says it makes herbal treatment more convenient is not correct. We are looking for the one that is not correct. Of course, we know that option B is the correct answer. However, let us look at the other one. Ferric cola is associated with its history. That is true. It copes with growing demand for drug. That is true, because as we cannot synthesize several drugs in the laboratory, and there is increased demand for drugs. Are you getting it? Because we can easily synthesize in the laboratory, we can synthesize analogs, we can actually modify old drugs to give more efficient drugs and more potent medicines. Are you getting it? So laboratory synthesis actually helps to cope with what? Growing demand for drugs. And that makes option D to be correct. To be also correct. So the one that is not correct is option B, which says it makes herbal treatment more convenient. Now, the product of the reactions are, now, we did something like this when we are talking about alkene, right? We say when alcohol react, whenever you see H+, know that you are talking about acid, if you can remember. Whenever you see H+, know that we are talking about what? Acid. Is that okay? Whenever you see H+, know that we are talking about what, my dear student? Acids. Is that okay? So we say when alkene reacts with H2SO4 in the presence of heat, there will be what? Dehydration. That means you are removing water. And if you are removing water, what will be formed is what? Alkene and water. Can you still remember? Now, what kind of alcohol is this? Let me do the reaction here. This is CH3 bonded to what? Then this one here is CH. What you have here, remember we said any center like this is carbon. How many hydrogen do we need to add? 2. So here is CH2, and then here is what? OH. According to the this thing we discussed the other day, plus heat, what do we say we are going to do? Remove this OH, dehydration, to form alkene. Remove this OH from here. Are you getting it? Then when we remove the OH, remove one hydrogen from here also, according to what we learned. So if we remove hydrogen from here, remove OH from here, you are going to form CH2. Here will be double bond, CH2, plus what? The H you remove from here, minus H from here. H removed from here plus OH from here will give us what? H2O. So this will form an alkene and water. And option A is very, very correct for this question. Is that okay? Option A is correct. Every other option here is incorrect. And what reaction is this? This is called dehydration of alcohol to form alkene. So go and study dehydration of alcohol to form alkene. It's an important question that you are going to see in the exam. Dehydration of alcohol to form alkene. Then the next question we have here. The hybridization of nitrogen in this compound is, here is nitrogen, this is nitrogen, right? What is the hybridization of nitrogen in this compound? Of course, you agree with me that here, 1, 2, there are 2 sigma bonds, 2 pi bonds, and 1 sigma bond. Is that okay? Exactly. So what hybridization is nitrogen in this compound? By virtue of what you have known. Are you getting it? What hybridization? Whenever you have 2 pi bond, 1 sigma bond like this, for nitrogen, that is what? sp hybridization. So option C is very, very correct. Now, high energy. Remember we said that alkanes, they need high energy to initiate them. Why? Because they are relatively unreactive. And we said that is the reason why alkanes are known as what? Paraffin. They lack affinity. Can you remember we did something like that? Exactly. High energy is needed to initiate reactions in alkane because they are relatively what? Unreactive. So that is very, very correct. Then the general formula for the class of compound. This is cycloalkanes. When I was teaching you alkanes, I told you that the general formula for alkanes is what? CnH2n plus 2. But this general formula is not applicable to cycloalkane, which have the same general formula as what? Alkene, which is CnH2n. So the general formula for cycloalkane is CnH2n, which is option B. It's very, very correct. The aromaticity of a compound is determined by the 4n plus 2 pi electrons and conjugated double bond. Which of the following compounds exhibit aromaticity? Now, in the exam, don't expect a structure like this. They are going to write the name of the compound for you. You should be able to determine the name of the compound. Are you getting it? They may give you naphthalene, toluene, different compounds. So better go and browse aromatic compounds. Some of the name: anthracene, toluene, naphthalene, benzene, and several others. Aniline. Are you getting it? Several other compounds. Because they are not going to draw the structure for you in the exam. Now, say the aromaticity of a compound is determined by 4n plus 2 pi electrons and conjugated double bond. Which of the following compound exhibits aromaticity? Now, the general rule is that for a compound to exhibit an aromaticity, that compound must be what? Must be a cyclocompound. It must have odd number of pi bonds, and it must be conjugated. It must have odd number of pi bonds, it must be conjugated, it must be what? Cyclic. Now, if you look at the first one, this one, wherever we see a double bond, one of the bonds is a pi bond and the other one is a what? A sigma bond. So here we have one pi bond, pi bond, pi bond, pi bond. This one has 4 pi bond. 4 pi bond, 4 is an even number, so this one is out. Now look at this one. This is 1, 2, 3, 4, 5. This one has 5 pi bonds. So we can say this one, about bond, this one is correct. This is 1, 2, 3, 4. About bond, this is wrong because it must have odd number. 4 is even. Then this one is 1, 2, 3. About bond, this one is correct. Now the next thing we are going to look at to answer this question now will be based on the conjugation. Now, if you look at this compound here, is it conjugated? This is, when we say something is conjugated, after double bond, what do we have? Single bond, single, double, single, like that. So if you look at this one, this is double, single, double, single, double, single, double, single, double, single. Are you getting it? And then we have double, single, like that. Look at this compound is conjugated. However, if you look at this one, this is double, single, 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 double. This is not conjugated, so this one is wrong. So the correct answer to this question is option B. Option B is very, very correct. All right, let's see the next one. This person got almost all the question correctly. Which statement is true about hydrocarbons? Hydrocarbons are non-polar and dissolve in polar solvents. Is that true? Hydrocarbons are non-polar and they dissolve in non-polar solvent like benzene and so on and so forth. So this one is not correct. It's not true. Melting point of branch chain alkane are lower than their straight chain isomer. That is not true. The melting point of branch chain alkanes are higher than their straight chain isomer. Boiling point, okay, no. This might be correct. Boiling point of straight chain alkanes are higher than their branch chain isomer. We are looking for the one that is correct because this one is not correct. The boiling point of straight chain alkanes are higher than their branch chain isomer. This is correct. Hydrocarbons are incombustible. Hydrocarbons are combustible. You can burn them. That is the reason why we say combustion reaction is a reaction that alkane undergo. Alright, so the correct answer is option C. The boiling point of straight chain alkanes are higher than their branch chain isomer. That is something that we have discussed in this class. The structure of Z2-bromopropanol. First of all, we need to know bromopropanol. All of them have the structure of bromopropanol. Now the question is, which of them is Z-isomer? I taught you E and Z nomenclature, if you could remember. We say in E and Z nomenclature, you divide the compound into two, and then you assign priority to the two groups attached to the same carbon. This is bromine, this is methyl group here. This is methyl. Whenever you see a chain like this is methyl CH3. So this like carbon that is here. So bromine and carbon, which one have the highest priority? Bromine have highest priority, while carbon is Z. This is oxygen, this is this. Oxygen has higher priority, hydrogen is B. So that at the end of the day, the two higher priority group are on the same side, the two lower priority group are on the same side. So you say this is Z configuration. Something we've done before now, right? Exactly. So if we say this is Z configuration, my dear student, what do you think will now be the name of this compound? This is already Z. This one, this is A, here is B, this is B, this is A. This one is Z or E configuration because the two higher priority group are on different sides. How about this one? This one is A, here is B because bromine has more priority than oxygen. Then here is what? B, here is what? A. This one is E configuration. How about this one? This A, here is B, here is B, here is what? A. E configuration. So you see all of them, they are even E configuration aside from this option A, which is Z configuration. Then the question now becomes 2-bromopropanol. How do you number? Now, according to the numbering nomenclature, if you bring this compound, let me bring it out here. It's going to give us something like this. C, here's what? CH3. Here's what? Br. Here's double bond. Here's what? OH. Here's hydrogen. According to what you learnt, when you want to number a compound of this nature, what do you normally do? You say here will be your number 1 because this one is the carbon kind, the OH. So here's your number 1. Here's your what? Number 3. Here's your what? Number 2, and here's number 3. At position number 2, you have bromo group.